Hello again, everyone. Welcome to the Postgres Google Hangout session. I hope you can hear me okay and see my screen okay. If not, please let us know via the chat window. Today, we are not only live on Google Hangout, but we are also live on Facebook. So let's get started. I am Sakshi from Ashnik. With me, I have Mr. Samir Kumar, who will run today's session. Samir is a database solution architect with Ashnik. A brief about Ashnik. Ashnik is an enterprise open source solution provider based in Singapore with presence across Southeast Asia, India, US, and the UK. We provide Postgres SQL solutions and services across these regions. We are also the master partners of Enterprise DB for Southeast Asia. In a series of Hangouts, we have been sharing the upcoming features of Postgres SQL version 9.6. In our last session, we discussed parallelism. Be covering streaming replication of version 9.6. So, hot streaming replication is about to get hotter, isn't it, Samir?
Yes, you will have much hotter replicas now in terms of in terms of the hotness of the data itself, which is being replicated. We will cover more about that later on.
Great, then over to you.
Thanks a lot, Sakshi, for the introduction and brief about today's Hangout session. So today, in series of our Hangouts about version 9.6 features in PostgreSQL, we would be covering more about streaming replication. There are new enhancements in streaming replication, which will literally make your standby more hotter as compared to how it would have been earlier. Today, we would be covering some details of streaming replication in PostgreSQL. We would also cover some topologies and use cases. We would be covering some of the existing challenges that users face and some of the new enhancements which are coming up in version 9.6. And we would see how those enhancements are exactly catering to the challenges which users are facing today. We would have a question answer round at the end of this session. While we are talking and I'm sharing about streaming replication, you can feel free to ask questions in the chat window or via YouTube comments. We are live on YouTube as well. This is an experimental trial attempt on YouTube, so we are not really sure about the audio video quality on YouTube for this first time. If you would want to watch it on Facebook, sorry, we are not really sure about the Facebook quality because this is the first time we are live on Facebook and Hangout both at the same time. You may want to check it out on our Facebook page. Do let us know whether it was good experience or whether would you prefer Hangout itself, so that we can make our next session better for you. Let's get started. I'm not going to elaborate too much on streaming replication. I'll just cover some brief details of that. We have done a couple of Hangouts in past, which covers streaming replication in bit more detail. Streaming replication is basically a wall-based or a transaction log-based replication. You can configure it to be synchronous or asynchronous. It is basically a shared netting architecture, and hence it ensures that there is no locking on the global cache and there is no contention on the network side, wherein you have to share the past image or there is single disk which causes some kind of contention. Those things do not happen in a streaming replication architecture. Here, the wall files are replicated from the live wall location, and you need not have an archiving setup. This has been further enhanced with version 9.4, where new feature of replication slots was introduced, wherein the master server would ensure that the WAL files which are not consumed on a particular standby slot are kept intact or are preserved and are not removed. There is no disk level mirroring required here, as every database server, the master and the standby, will have its own database location and disk. And your standby server is capable of accepting read queries. Now, this particular aspect of streaming replication is very interesting, and that is why sometimes the standbys are called hot standby. And that is exactly which is about to get hotter in version 9.6. Now let us look at some of the topologies which people achieve with streaming replication. One of them is obviously to have a highly available database setup. You can do a manual failover or an auto failover. If you want to enable auto failover, there are a lot of tools available. Pacemaker CoroSync is one of them. If you want a tool with support from or which has a commercial backing or backed by a support team, you can use Enterprise DB's failover manager, which provides you a feature which you can see on the screen. You can have a master database or a primary database and a standby database. Your application always connects to the master database using the virtual IP. If there is a failure, the virtual IP shifts over to the standby DB. You can achieve this manually as well without using any tools, in which case the promotion of standby will have to be done manually. A step further from that is the next architecture, wherein you can do some bit of load balancing. You can use pgpool, which is another open source community project, and you can use that tool to load balance the read queries between master and the standby database. pgpool is capable of identifying the right queries, and it can send those right queries to the primary DB. And read queries will be load balanced. All the write queries happening on the master database will be replicated to the standby via standard streaming replication. You can also achieve no single point of failure by setting up pgpool on your application server itself. If you don't want to set up pgpool on the application server, you can set up pgpool on standalone servers, and you can have a replica of that pgpool, and both of them could be working with watchdog mechanism, which enables high availability at pgpool level. For keeping this session brief, I have not included that particular architecture diagram in this presentation, but if you are interested in going through that, please follow up with one of our previous sessions, which is about building a scalable cluster with PostgreSQL. It was covered in one of the Hangouts last year, and the recording should still be available on YouTube. I have included a link to that at the end of my presentation. A lot of people also set up replication with multiple standby databases, and they would want to do a failover or a switchover, after which the standby or the roles could be switched. So as you can see in this particular topology, there is one master server and two standbys which are replicating from the same master. And if there is a switchover or a failover happening, the master is or the role of master is assigned to the second server, and third server starts pulling the stream from second server after a restart. There is no need to have archives in place for this particular setup. And this is facilitated since version 9.3, wherein the timeline switch info is recorded in the WAL files itself. This is further enhanced with version 9.4, wherein you can ensure that with replication slots, one of the servers is retaining the wall files, and they are not being removed until and unless they are being consumed on the standby. You can also set up cascaded replication, wherein a primary database is replicating to a standby, and that standby could be replicating further to another standby DB. In this mode, the standby DB could be in the same site or it could be in another site. This ensures that the network overhead on your first or the primary DB is very less. You can have any level of replication in this case, or any level of cascaded setup in this case. There are some of the existing challenges which people who are setting up high availability or load balancing clusters with PostgreSQL, they are facing some challenges, and let us discuss some of them. For some people, wall level could be confusing. There are multiple options currently available in wall level. You have hot standby, you have archiving. We will look at that in a while. The base backup or the PG base backup command does not set the replication slot name. So we will look at this particular limitation as well in bit more detail in a while. Another limitation is when you are doing a load balancing setup, wherein the read queries goes to the standby database, you cannot ensure that your standby is always exactly up to date with the master. Even with synchronous replication, you cannot be sure about it. And we will look at the reasons in a while. We will also have a demonstration of why is that so. And you cannot have multiple standby servers which are following the master synchronously. At a given point of time, you can have only one synchronous standby. Though you can specify a list, but only one of them would be following the master synchronously. There is no effective way of finding out which is the upstream server, especially in a setup like this. If you want to find out which is the upstream server from where the wall receiver is receiving the wall stream, it is very difficult to find out which is the upstream server. The only way so far is to find out it from recovery.conf, and it has its own flaws. Now let us look at the enhancements in version 9.6 and see how they are helping the situation so far. What I mean is the situation or whatever is the challenges which people are facing so far. How are these new enhancements going to tackle them? So earlier, like I mentioned, wall level has got two different options, hot standby and archiving. But you can set up a standby server even with wall level set to archive, but it does not allow the standby server to be used for read queries. And sometimes people end up in that situation where they think that with archive setup, they can set up a streaming replication. Well, yes, you can do that, but then your standby is not a hot standby. It is just a warm standby, and you cannot use it for read queries. This could be really confusing, and I have seen people with really good experience getting confused in that particular concept. Some people tend to believe that you need to have hot standby as your wall level to enable replication, which is not true. And because of all this confusion, in version 9.6, the wall level has been normalized. So it is pretty simple now. The minimal value, it means that this is a standalone server and it can only be used, or it is only capable of single phase recovery after a crash. So your database crashes, your wall will have enough data to recover those transactions which were not yet checkpointed. But when you set it to replica, you can archive your vol files and use it for point-in-time recovery. Or you can set up vol senders by increasing the number of vol sender on the master and use it for replication. When you use logical, you can use your vol files for logical decoding or for setting up logical replication. There are various tools which can help you set up logical replication. You can also use your custom homemade scripts, but there are many other tools which are available like XDB replication version 6.0 from Enterprise DB, which allows you to do logical replication from one server to another server. Of course, both of them needs to be running Postgres, and the master should be running Postgres version 9.4 or above. Archive and hot standby values are still supported in vol level, but they are mainly for backward compatibility. For having any specific meaning, they both map, and if you set them up, they both map to replica. They don't have any individual meaning of their own. Well, another challenge which people were facing was about usage of replication slot. Now, in version 9.4, replication slots were introduced. So you can set up a replication slot on the primary and then use that on the standby. Now, primary will ensure that unless a particular vol file has been consumed by the standby, which is using a particular slot, those vol files will not be removed. This is particularly helpful when you have to shut down a standby node for maintenance purposes. But at the same time, when you're using replication slots, you cannot make use of another feature which was introduced in version 9.3, which really made the replication a two-step process. In 9.3, there was a new option introduced in PG-based backup. So all you had to do was use PG-based backup with write recovery conf option that you see on the screen, and then start the standby server. Now, in version 9.6, this particular limitation has been taken off because there is a new option called slot, which is available in PG-based backup. When you use that, one advantage is that all the vol files are preserved until the backup completes. Now, previously, if you would take a PG-based backup, as you can see on the screen, if you're not using slot option, what you would get is a warning that archiving is not enabled, and you have to manually ensure that all the vol segments have been copied. This is a particularly annoying situation, especially when you are adding new replicas on the fly. So if you're setting up replication in the very beginning, this does not really matter much. But if you're adding replicas on the fly, this could be really troublesome. Now, with 9.6, as you can see, you can create a new slot on the primary server. That is what you see as the first statement on the screen. And then, while taking the backup on the standby server, while running the backup command, you can specify the slot name. And as you see, this time there is no warning, because while the backup was going on, the primary was making sure, the primary server was ensuring that all those files are being retained. All those files which are there are being retained. All the files which are required for the backup are being retained. And then it's a step which I have done. SED is a command which I have used to replace the port number. This is basically needed because I'm running the standby on the same machine. But if you are running them on separate machines, typically you would not need to do that. Another important fact is if you're using slot name in the PG base backup command, you must be using stream method. So that is why you see that -x and small s option being used. Now, as you can see, once I have done that, all I need to do is start the standby server. It automatically starts using the replication slot which I had created and the one which I had used in the PG base backup command. I don't have to go and manually edit recovery.conf. I don't have to do anything here. So this particular feature helps you set up replication in a much faster and efficient way, setting up new replicas on the fly. Sorry, I'm taking pause in between at times. This is specifically because we have some challenges with our streaming on Facebook. And if you're hearing some pauses on the Hangout session at times, please don't worry. It is still live, but I have to take some pauses so that our Facebook audience is also able to catch up. Now, there are certain other challenges when you are setting up synchronous replication, and this people who have used synchronous replication would be aware of. One of them is you can only set a list in synchronous standby names, and only one of them would be following your master. And even when you set your synchronous commit to on or remote, which means basically these two parameters force one of the standbys to be synchronously following your master. And even when you set your synchronous commit to on or remote, there is a chance that the standby, a query on the standby would return stale data, because synchronous commit only ensures that wall records have been replicated. It does not ensure that they have been applied by the standby. It only ensures that it has been received by the standby. There's a difference between that, and this we will see on the next slide. If you notice here, my synchronous commit on the master is on. My synchronous standby names is set to one particular standby name. And next couple of commands shows that what is the state and what is the standby name for my standby, which is currently active or which is currently streaming from the master. When I insert one particular row on my master, I can see that it is instantaneously replicated to the standby. Whereas if I pause the recovery, now I have to use pause recovery. In your production environment, you don't really have to do this, because I have to use this so that I can forcefully simulate a situation where a wall record has been received by the standby, but it is not yet applied. Now, when I pause the recovery, standby server continues to receive the wall file, but it would not apply them. It would not apply the commits. Now, in this setup, I'm sending one more insert statement to my master, and I can see that that particular new statement or this particular new record is not yet replicated because my recovery has been paused. But if you don't do this particular step where you don't pause your recovery, and on your production server you have very heavy write load, this situation can come. You might come across this particular situation, and you may face this scenario where some transaction has been replicated from the master to the standby, and it is yet not applied. And in the meanwhile, one of your sessions tries to read from the standby. Now with version 9.6, what would happen is you will have a new option. You will have a new value for synchronous commit, which is called remote apply. Now in this case, if you see, I have the same setup, exactly same environment. Only difference is on my master, synchronous commit has been set to remote apply and not on. Now in here, when I pause the recovery and I try to create a table, that transaction actually was hanging for a while. And when I canceled the statement, the warning which I got is there on the screen, which conveys that the statement has been processed on the local database, but it is probably not replicated to the standby. And this is much more stricter than synchronous commit being set to on or remote, because here it really ensures two safe commit, which means that some data which has been committed on the master has also been applied and committed on the standby. This will basically ensure that if you are trying to read something instantaneously from the standby, it will return exactly same value which your master database should be returning. This ensures consistency in a read balanced cluster setup. And this is why I said that the streaming replication is about to become even more hotter, because your replicas are much more hotter in terms of the data that they contain, in terms of the transactions that they hold, or rather the transactions that have been applied. You can have more hot standbys now with 9.6. Like I said in the beginning, one of the challenges which people face is, though you can specify a list in synchronous standby names, only one of them will be synchronous at any given point of time. And this poses a challenge for those enterprises who want to ensure that data must be replicated to at least 2 servers, or data must be replicated to at least 3 servers. Now with 9.6, in synchronous standby names, along with the list, you can also specify a degree. Now in this particular example that I have shown here, I'm setting it to 2, and within brackets, I'm specifying a list. This means that there are 3 possible standby servers which could be replicating, but at a given moment, only 2 of them would be following synchronously. So this will ensure that when I commit a transaction on the master, they are replicated to standby 1 and standby 2 if they both are available. In case standby 1 is not available, it will be replicated to standby 2 and standby 3. If standby 1 and standby 2 both are not available, it will be hanging, or it will wait for a standby server to come up with application name set to standby 1. Another challenge which people face is about finding the upstream server. I'm not exactly sure if the screen resolution is very good for you to read it out. But what I have done is I'm using read file command, read file function in PostgreSQL to read my recovery.conf, which shows that the master server is set to 192.168.209.128. But when I check when was this file modified, it tells me that the file was modified at 2:08 p.m., whereas the postmaster has been running since 1:50 p.m. This means that this method of finding the upstream server is not effective if your recovery.conf has been modified since the last read. And this is a valid scenario, specifically when people are applying patches and you want to remaster your configuration, and then administrators tend to get confused that, oh, which was the primary server, or which is the primary server from where I am pulling the vol stream right now. And since you have already modified your recovery.conf, you don't really have an option of finding that out. So that is one of the challenges with this method that people tend to use so far. Another challenge which is with this method is it does not really tell you much information about the replication status on the standby server. So you cannot tell about the status of replication just by looking at the standby server. In 9.6, you have an alternative and much cleaner way of doing that with pgstat vol receiver, in which you can find out more details about your upstream server and more details about your standby database. As you can see here, you can find out about the log, what is the last log received, what is the timeline on which it started replication, what is the current timeline, and then you can correlate that with the timeline of the server which you are presuming to be the master. You can correlate this with pgstat replication on the master, and then you can find out more details of your replication status on the standby as well. For further information, I have added some more additional literature that you can go through. A lot of details can be found on the online PostgreSQL documentation. I have myself gone through a lot of them on PG base backup and in replication configuration parameters. There is a document published by HP Enterprise, and which has quite a lot of details of new features of 9.6 with some examples as well, and you may find it useful. These slides which I have used for this particular presentation would be uploaded on our SlideShare. Apart from that, to get more understanding on building HA cluster with streaming replication, or to get basic information on streaming replication, you may want to go through one of our past Hangouts. I have listed them in the slides and you can go through them. Feel free to post your questions. Let me switch back to the questions tab. In the meanwhile, take note of our Facebook, Twitter, and Google Plus pages. And feel free to drop us an email on success@ashnik.com if you have any suggestions or questions. Well, here is a question that is asking whether the old way of setting the synchronous standby names, is it still applicable? Yes, it is still applicable if you specify just a list without a degree and without round brackets or parentheses. It will default it to degree 1, and it will behave same like how it was working earlier. No, still the cascaded replication cannot be synchronously replicating. So the question is, can the standby which is cascaded can it be synchronously replicating from another standby? No, it cannot. Okay, one last question, which is about the setting of the degree, which I mentioned, the synchronous standby names. Can it be changed in runtime? This is a question which even I had asked when I was listening to Magnus talk at PGConf at New York, and he had also clarified that no, at the moment you cannot change it at the transaction level, though you can change it on the fly and reload your config, but you cannot change it at the transaction level. If you change it, it will be applicable for all the future sessions. So make a note of that. Moment not possible that you set the degree of synchronous replication per transaction, so that some of the critical transactions go to 3 replicas. Those transactions which are not critical goes to just 1 replica. Bad jobs, you're not really replicating them synchronously. Though you can still set your synchronous commit to different values per transaction. All right, if you have any further questions, feel free to put them under comments on our YouTube page. This video will be soon uploaded as a recording on our YouTube page. It is instantaneously after the Hangout concludes. Thanks a lot for joining us.